I think this is a great question on Leibniz notation and just in general the notation of the derivative. There's a few different ways it can be written, and typically here, right, what does dy over dx mean, or df over dx? That is how the function is written. So you might see something like y equals f of x equals x squared plus 2x, or something like that. This is just a name of the function. We're able to write the function implicitly in terms of x, but that's not always the case. You might have something like some function as a term of x and y, and you might have to do implicit differentiation. So here's some different notations. This is the derivative of the function f with respect to x. This notation is also the derivative of this function with respect to x. You might also see this, dx of f of x. This comes up in kind of differential equations in some upper level math courses. Calc 3, you might see this again because you might be taking partial derivatives. So this tells you what we're differentiating in terms of. And then you can also see it written with a little tick mark. Yeah, so if I'm saying something like the derivative with respect to x of some function, x squared plus 2x, I could write it like that, or I could name this function y, x squared plus 2x, and I could say the derivative of y with respect to x. In this case would be 2x plus 2. This case would be 2x plus 2. So I think it's great questioning what's going on here. So the dy over dx, in 2 words, is the derivative of the function y with respect to x. This is very important. That comes up when we differentiate functions with respect to time. So we might have a function y equals, let's do x squared plus y squared equals h squared. This comes up later on in the course. I have x, y, h. So I might have some related rates problem where this might be a ladder that's sliding down the wall. And when you differentiate this function, you're going to differentiate it with respect to time because x and y are functions of time, right? So you want to keep in mind what your function is with respect to. A lot of times it's respect to x, but it could be with respect to t or any other kind of notation. Hopefully this kind of clears up some of the different ways you can write a derivative and manipulate the function with respect to a certain variable. A lot of times it's in terms of x, but in physics and applications, the functions will be in terms of time. So you might also say find the derivative with respect to time. And in the related rates problems, you'll definitely be doing it with respect to time. So you want to remember that x and y are both functions of time. So this would be 2x dx dt plus 2y dy dt. And then h would be a constant if it was a ladder, right? It might be a 5-foot ladder. So then the derivative of a constant is 0. So here this might be 5 squared. The derivative of 5 squared is just 0. So this will come up later on. So you might be seeing something like this, the derivative of x with respect to t and the derivative of y with respect to t.